Good morning. Today we're going to take a look at angle theorems in geometry. In last lesson we talked about polygons, and some of those angles and properties will still pop up again, and that's fine. But think of this as more of a thorough properties that you may have seen from grade 7 and 8, and that's perfectly fine. So we're going to use angle theorems to help find missing angles. And we're going to take a look at parallel lines as well. All right, so here's some theorems that we've learned maybe in the last couple of days. So we know that some of the angles inside of a triangle add up to 180. So we know that in our minds that these add up to 180. So x plus y plus z is 180. Okay. The last lesson we talked about supplementary angles. So think of it as a straight line. That's 180 as well. So x plus y equals 180. That's the idea of it. Complementary angles are things that add up to 90. Okay. So I don't think those three are too bad. So vertical opposite angles, basically vertically opposite angles are equal. So if I took two straight lines, and let's say that this angle was 80, okay, how could we prove that that is 80 as well? Let's try that. Well, interesting enough, it's true, and we can actually use the supplementary angle theorem that we'd have there. We know that y has to be 180 minus that because it's 180 degrees, right? So that's got to be 100. But these guys are complementary angles as well. All right, so I gotta do 180 minus 100 to get my 80 again. Well, guess what? I gotta do the same thing down here. All right, so the idea there is these are opposite angles, and these are vertically opposite angles. So that's what we're kind of take a look at. So we're looking at, hopefully that made sense. Exterior angle theorem. Okay. Any exterior angle is the sum of two non-adjacent interior angles. What does that mean? So if I'm looking at this scenario of x, y, and z, and I'm actually going to show you a little bit of a proof here. All right, is if we knew that x plus y plus z is 180, and we also know that w plus z is 180. Well, we're actually going to show you, we're actually going to prove that x plus y is equal to this exterior angle right here. Okay, so we're going to try to prove that. So what I'm going to do is, first thing I'm going to do is, I'm going to, let's say, let's get rid of that. I'm going to solve for z on my right side here. So I'm going to, if I subtract w from both sides, I have z is equal to 180 minus w. All right, just to prove this. And then what I'm going to do is I'm going to sub z equals 180 minus w over there. Okay, so that leaves me with x plus y plus 180 minus w equals 180. Well, okay, so let's get rid of the brackets. So plus doesn't change any signs in there. Plus 180 minus W equals 180. Okay. So let's subtract the 180 here. Oh, 180 is gone there. So I've got x plus y minus W equals 0. Well, how do I get that scenario? Well, let's add W to both sides. So that leaves me with this. Well, I proved it. Okay. So I've used a little bit of algebra, an algebraic proof to do that. So if we're using this as an example, let's say this is 70 degrees and 50 degrees. Well, to figure out Z, we could do 180 minus 70 and 50. But my W here would be just 70 plus 50. All right, that's 120. Okay. But you could say this is 60, then 180 minus 60, get the 120. Works both ways. Okay, so that's what that meaning is. Okay. So the two inside angles, there's my interior. So those interiors add up to the exterior of the other one. Okay. All right, let's take a look at one. Exterior angle theorem, we kind of did that last lesson. They're always 360. All right. Isosceles triangles. I have two angles that are opposite, two equal sides. So these two angles are the same. All right. Equilateral triangles. All right. Those are all the same as well. Okay. So that's it. I don't think that's too crazy, and I think we dealt with a lot of that in previous learning from grade 7 and 8. Here's the big learning, and you might have seen different letters with this. Parallel lines are always the same distance apart, therefore they never intersect. When a transversal crosses two lines, so this would be my transversal. All right, eight angles are created. Okay, not too bad. Well, let's see what we're asked to find here. All right. Well, we have three letters that we can create: the Z, the F, and the C. And these properties allow us to solve problems. So when two parallel lines are cut, all right, the transversal, the alternative angles are equal. So if I'm looking at this, the armpits of the Z are equal. The armpits of that angle and that angle are the same. For the F, the armpits of the F are equal as well. Okay. And the C pattern's a little bit different. These add up to 180. So think of it almost like a kind of a straight line a little bit. Okay, so we're going to use these properties to help us to solve problems. Okay. So let's jump into this. When using angle theorems to find missing values, you need to make an equation. Find the unknowns in each of the diagrams, show by making equations. Make equations. Simple as that. Okay. So what do we know from part A? Well, we know that we have a vertical opposite angle. Well, that makes that 40 degrees. Well, now we can make an equation. We can say now that x plus 60 plus 40 equals 180, because this is a triangle. All right, so x plus 100 equals 180. Using our rules, right? X equals 180. Pretty good. All right. All because we took a property that we knew and did that. Okay. Here's another problem. I got to solve for A and B. Well, what do we know? Well, can I add A plus B and 25 to solve for A and B? No, but maybe I have a supplementary angle. All right. All right. So I have a supplementary angle with the A and the 15. So we know that A plus 115 equals 180. All right. So now I know that when I'm solving equations, I can say now that that's 65 based on subtracting 115 from both sides. All right. Now I can put that in there. All right. Now I've got my triangle that I want. All right, so I know that 25 plus 65 plus B is equal to 180. All right, I know that 25 plus 65 is 90. Okay, and then I could say if I subtract 90 from both sides, I get 90 degrees. So that is basically the idea of setting up an equation from the given property. So know your property. Okay, so this is my property. Then you make your equation. All right, property equation. Oh, now interesting. All right, C. Let's see what we got here. Well, in C here, we have a supplementary angle. And sometimes it helps to give like another letter that if we need to, we can figure that out. Okay. So we know that 144 plus h is equal to 180 because it's a straight line. So that would be 180 minus 144, 36 degrees. Okay. So we know, based on that, is this angle now is 36 degrees. Okay. Well, how do we find G? We have a triangle. We know that's going to add up to 180. What do we know? Oh, what do these mean? I have equal sides. This must mean isosceles triangle. Therefore, this guy has to be 36 degrees. Okay. So now for my isosceles triangle, we know that we've got 36 plus 36 plus 8, G gives me that 180. Now I click like terms. All right, and then I can take 180 minus my 72, 108. Okay, so it's understanding the property, then making the equation. All right. Ooh, this is trouble. All right, let's see what we got here. We got to find x and y. So we got to find this guy and this guy. Well, Can I find y right away? I don't have any straight lines. I don't have, I don't know x, but maybe I can solve for x first. All right, so I'm going to stop here, and I want you guys to try and solve for x and y and give it a try. So I hope that you said that I got to find the supplementary angle. All right, so I know that this is a straight line. All right, so that means that this angle has to be 96. All right, I'm going to push pause again, solve for y. So hopefully when you did that, you knew that they had to add up 180, put in the angles that you knew, and then you can solve. So hopefully that's kind of a basic with that. I don't think that should be too much of a trouble. All right, but try to solve for the ones that you can solve for easy. Pick the easier ones to solve for first. All right, so let's go on to 2. All right, so 2 is a little different. All right, the question is what's different about it? Well, what do we know? Well, if we look at this picture, there are some angles that we can find. But if I'm looking at the picture itself, there's one piece of given information that usually is usually hidden. Parallel lines. How do we know? Well, these markers right here tell us that they're parallel lines. So you're looking for these markings. All right, that tell us that. This is saying that we're going to use some of our F pattern, maybe C pattern, or my Z pattern. All right, as soon as you see that, those patterns probably come into play. Okay, so let's look at this. I've got 42 and 65. It looks like it's probably going easier to find P first, but P is going to be related to R as well. So let's give it a go. So what do we know? Well, what are some things that I can solve for easy? Well, if I'm looking at that, I have a triangle. All right. Well, I know that, let's call this PR, let's call it M. It doesn't matter. Make up a letter. Okay. And let's see what we can do. We can go M plus 65 plus 42 equals 180. Well, if I look at that, I can say 65 plus 42, so that's 107 equals 180. And then I can do inverse operations to subtract that off, so that is 180 minus 107, 73. Awesome. So if I'm looking at that, how do I solve for M now? Well, what do we know about M and P? Hopefully you said that they were vertical opposite angles, which means that they're equal. Therefore, P is equal to M. Therefore, P must equal 73 degrees. Okay, so that's some thinking that goes with that. Okay, so we found out that this was 73. We found that out as 73. Okay, and now we can work ourselves up to R based on what we found for P, because these are two parallel lines. So if we look at this, I might say to myself, you know what? Let's find this angle right there. All right. Well, if I look at that shape there, all right, let's call it P, let's call it T. Okay. And you can use any letters, it doesn't matter. As long as if you introduce a letter, it helps you to really solidify your answer. Well, the C pattern says that they have to, the sum is equal to 180 degrees. Well, if I take 73 plus T equals 180, I can work backwards to say that is 107. Okay. And then from there, maybe I have vertical opposite angles for T and R. Therefore, I can say R is equal to 170 degrees. All right. There's probably other ways of doing that too. You're asking yourself, oh, well, I could have did supplementary angle and then the F pattern. Perfect. There's no problems with that at all. This is just one way. All right. I could have. There's many other pathways when you have parallel lines. All right. So I'm not saying that you always have to do one specific way when it comes to parallel lines, as long as you justify your thinking. Justify your path that you take moving forward. All right. What do we have here? Intriguing. So what I'm going to do is I'm going to let you sit on this for a second. And I'm going to tell you that you can solve for x and y independent of each other. And that's okay. So what I want you to do is I want you to think about this, and then I will come back with what I have, and both will kind of work out. So hopefully when looking at this, you saw that you see a C pattern right there. And then I can say, well, C pattern, they have to add up to 180. I can figure out that as 76 degrees. All right, because of these are parallel lines. Okay. Now, what we can do is, okay, we've got this as 76. Okay. The question now is, how do we find y? Well, we had these markers here. And if you look at those markers, what does that say? Well, that says the isosceles triangle. So if we knew that angle and those two angles, I could figure out how to do that. Well, what do we know about this part as well? That's a supplementary angle. And so let's call that maybe W right there. Well, if we take that, we can figure out what W is from that. So we found that as 76 degrees as well. So that part right there is 76. Some people would have said, could have also said, I could have said that that was a Z pattern, because there's my Z as well. Perfectly no problem. But in an isosceles triangle, I have two equal angles. All right, then I can do 180 minus those two 76s. Well, that's what I did there. So that's how I got that information. But it's all based on the property. Define the property and make an equation. That's the goal. All right. All right. So this is going to be the last one, and then we'll shut it down and let you guys try it. A Ferris wheel has 6 sides of equal length. Oh, ding, 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 ding. These are equal length. The exit ramp of the Ferris wheel is in the shape of a trapezoid. Okay, so this guy here is a trapezoid. Let's maybe not put trapezoid there. Let's put trapezoid down here. At an angle of incline of 20 degrees. Solve for x and y. Use properties. So I've got my hexagon. And if you remember from the last lesson, we have a polygon. We have a okay. So if we have 6 equal sides, we should have 6 equal angles. Well, let's find the sum of the interior angles. So we have to think, oh, how did we do that yesterday, or my last lesson? Well, we knew that that was n minus 2 times 180. So remember, we had 6 sides. That changed it to 4 triangles. All right, and I can put that together. That was 720. Well, we knew that these were equal sides. So we have 6 equal sides. Oh, actually, let's introduce another letter here. Let's call that maybe W. We know that 6W equals 720, and I divide by 6, and we get 120 degrees. But that's not what x is. Okay. So, the question now is, how do we find for x? Well, not sure yet. Well, we also know from a trapezoid, we have parallel sides. So that means those 2 sides are parallel. Well, if I'm looking at that, so that means that we have the C pattern, which means that I have y plus 20 equals 180 degrees, because that's what it adds up to. So we know that y is equal to 160 degrees. So in this case, we actually had to solve for y first. Is it wrong? No. All right, but in your mind, sometimes you say, oh, I gotta find x first before y. Not necessarily. You just take what's given to you. All right. So that kind of helps, because now we can say that we have a circle using x, y, and w now. And now we can say that, let's continue with that. Now we can say that 160 plus the 120, because that was the inside, plus my x, because if I look back up here, x is on the outside. That's going to get me my 180 degrees. Well, 160, well, 360, because it's a circle. So I know that adds up to 280, plus x gets me my 360. And if I use inverse operations, I believe that 360 minus 280, there, 80 degrees. All right. So that kind of helps me with my thinking. But everything, we have to do problem solving. We have to try and error. All right. And feel comfortable with making mistakes to get to the answer. Okay, so give those a go, and we'll talk soon.